Hello, uh, I'm here to explain about the 7408 IC. 7408 is nothing but an AND gate, 2-input AND gate. The 7408 IC is a 14-pin IC. Is a 14-pin IC. This 14-pin IC, two pins of which you will be giving the power supply plus VCC and minus VCC to the 7408 IC. And as I said, we have 14 pins, remaining 12 pins. We will be having 4 gates in this IC, 4 AND gates in this IC, 2 input gates and 1 input pins and 1 output pin. Similarly, we will be having 4 gates. We will be connecting this and verifying the truth table. We will be connecting it and verifying the truth table for all the logical combinations, namely 00, 01, 10 and 11 via an LED. And AND gate, we know only for one logical combination you will be having 1. Okay, so the LED has to blink only for that logical combination. For the other 3 logical combinations, it has to be 0. It has to be 0. So this output pin from 7408 will be connected to the current limiting resistor as given here. The current limiting resistor, it is shown here. One end of this current limiting resistor will be connected to the output pin of the 7408. I'll show when we are doing it, performing it, the experiment. Other end of the resistor will be connected to the anode of the LED, and the cathode will be connected to the minus VCC, otherwise said to be ground. Minus VCC, otherwise said to be ground. Okay. So now let us find what is the value of this current limiting resistor. The first band is an yellow band, the next band is a gray band, and the third band is a brown band. Yellow band, and you know how to find the color coding of the resistor. B.B. Roy, Great Britain, Very Good Wife. So yellow band is nothing but the value of yellow is 4, and gray band is 7, whereas multiplier is 1. Multiplier, so 10 power 1, 47 into 10 power 1, that is 470 ohms. That is 470 ohms. Okay. Please look here. Whatever it is pointed out, the yellow, gray and the brown. So yellow is 47, gray is 7, and the brown band is in multiplier as I said earlier, it is 10 power 1. 47 into 10 power 1 is 470 ohms. So already this 7408 op amp is inserted in the breadboard. If you want to verify the resistor value, you can verify even via the multimeter. See, it is showing 466 with it, because you will have a plus or minus 5% tolerance. So the value may change. You won't get exactly 470 in the manufacturing process. Here for 7408 I'm sorry, I'm repetitively saying op amp. It is an logical IC. It is an AND gate IC. So here as I said earlier, to power the op amp, we need to give plus VCC and minus VCC. That will be given through a regulated power supply. This is regulated dual DC power supply. So the left, you have a power button that is on, that is pressed on. Okay, so you can vary up to 0 to 30 volts using this regulated power supply. For powering the IC, we need 5 volts. 5 volts. So you will be placing 5 volts using this regulated power supply. The left hand side is a coarse knob, and the right hand side is the fine knob. You will adjust the coarse for making larger variations, and then for fine adjustment you will be using the right side knob, that is nothing but the fine adjustment knob. Here below this knob, below these two knobs, this is coarse and this is fine, and see, it is switched on. Using this, the LED is blinking. You can vary, this regulated power supply can be varied up to 35 even. So using the coarse and the fine, we will be doing it. Okay. And then this red and the black stands for the plus and the minus of your power supply VCC. So the plus VCC will be given to 14th pin of the IC. 14th pin of the IC. See here, there will be a notch here. So in the notch, left side of the notch, okay, when you take an IC and see, top will be the notch. You have to place it in such a way that the notch should be in the top, and left side of this notch, you have to begin the number as 1. So from the top, again from the top, from 1 2 3 4 up to 7, you will be having 1 2 3 4 5 6 7, you will be having. And I have to come down, and from bottom to up I'll go for 8th pin, 9th pin, 10 11 12 13 and 14. 14th pin, the topmost pin in the right side top, that will be your VCC plus VCC. So from the RPS, positive will be taken, that is from the red color knob. A positive wire will be taken, and then it will be given to the 14th pin of your 7408 IC. 7408 IC. And now the 7th pin is the ground, otherwise said to be minus VCC. So that will be taken from the black knob of the power supply. Black knob of the power supply, it is inserted. Okay. Now the first and the second pin, as I said, we have 4 logical AND gates in this IC. Let us take the first gate. The first gate input pin is 1 and 2. 2 input pins is 2 logical AND gate. The third pin is the output. Two wires we have inserted for giving the input in the first pin and the second pin. The first pin and the second pin. Look here, this is the breadboard connection. I hope you are familiar with the breadboard connection. You have 4 segments in the breadboard connection, 1, 2, 3 and 4. And in the segment 1 and 4, connection will be similar. 2 and 3 connections will be similar. In the grid, in the segment 2 and 3, all the vertical dot points are connected vertically. You have a vertical grid connection here. 5 dots will be connected vertically. Whereas segment 1 and 4, you have two horizontal rows, 1 and 2, and similarly here also you have 1 and 2. So altogether segment 1 and 4, you have 4 horizontal rows. Keep in mind, each row will be having 50 dots. 25 dots will make a connection. 25 dots will have a connection, and the next 25 dots will have a same connection, meaning all the 25 dots are at same potential. Similarly, the next 25 dots will be at same potential. if you want to establish a connection between the first 25 and the left 25, you have to do it externally by connecting a loop wire between the first and the second 25 connections. Okay. So now in the middle connection, as I said, all the vertical points, namely 1 2 3 4 5, that makes a potential. Vertical grid points will make one potential. In the IC, it's a 14 pin IC. Each pin should be maintained at different potential. That is why it is being inserted in the vertical grids. See, while we are inserting in this way, each pin will be in one vertical grid, one after the other. So every pin will be at different potential. So we have already inserted 2 wires for giving the input. For the AND gate, and the third pin is the output pin that has to be connected to the LED. You should not connect the LED directly to the output pin. You should connect a current limiting resistor, and then via your current limiting resistor, you have to connect your complete your connection for your LED. So now we are inserting the resistor here in the third pin, and then the other end of the resistor will be connected to anywhere in the breadboard. And see here, from the same potential you have to connect the anode, and the cathode should be connected to minus VCC. Instead, here we are giving it in the grid 4 and the horizontal pin connection. and since it is negative, we have to give negative for the cathode. We already minus VCC is connected to the seventh pin. From that we can take a loop wire and we will connect to the segment 4 in any of the 25 pins. Okay, any of the 25 pins. See here, we are connecting it to the second 25, both the LED and the ground. Okay, and now we are going to give the power supply. This 7408 we need 5 volt power supply, so we will be adjusting the coarse and the fine and set it at 5 volts. We will be setting it at 5 volt. Look at the pin diagram and the truth table of the 7408 NAND gate. AND gate. So 14th pin is a VCC plus VCC and 7th pin is minus VCC. We will be having 4 AND gates, 1, 2, 3 and 4. So we are making use of the first AND gate. 1, 2 we have taken 2 wires out. Via this we will be giving the logical combinations, namely 0, 0, 0, 1, 1, 0 and 1, 1. See, this is a truth table. This is the truth table, and in the truth table, you know the truth table of AND gate. For 0, 0 it is 0, 0, 1 it is 0, 1, 0 it is 0 and 1, 1 it is 1. Okay. So here the positive VCC and the negative VCC, we will be giving the 5 volts plus and minus 5 volts from the regulated power supply. And see your input combination logical 1 and the 0. In terms of voltage level, if it is logic 1 you will be giving plus 5 volts, if it is logic 0 you will be giving minus 5 volts. Logic 1 meaning plus 5 volts will be taken from this 14 pin and it will be looped and it can be given to the first pin if we need logic 1 to be given at the pin number 1. And if we want to give pin number 0, logic 0 in pin number 2, namely 1 0 combination, the third combination, we will be taking a loop wire from pin number 7 and we will be connecting it here, that is minus 5 volt, which is otherwise said to be ground, that will be given. So 1 0 combination, the LED should not blink, it should be 0. That can be verified by giving the connections. Already we have given the plus VCC and minus VCC, namely for 5 volt by using the regulated power supply in the breadboard. Okay, this truth table we are going to verify. So using the coarse and the fine knob of our regulated power supply, we will adjust and give it to 5 volt. Okay, right. Later, let us check with the all the 4 logical combination. First 0, both are 0. First combination, both are 0. Since here the cathode of the LED and it is looped to ground, so that is, it is minus 5 volt. That is nothing but ground. So when we are connecting both the inputs to ground, see the LED is not blinking. It is off. It is off. Right. So now let us give 0 1 combination. 1 is 0, another one for 1 combination we will be giving in the 14th pin, namely plus VCC. 14th pin, namely plus VCC, we will be giving, yeah, in the same potential. Again it should not blink. Okay, 1 0 and 0 1 combination both are same. When 1 1 combination, both should be connected to 14th pin, that is plus VCC. See, the LED is blinking. Could you be able to visualize it? The LED is blinking now. Right, we will be giving both the connections to 14th pin of the IC. Similarly, see, again 0 0 we have given and 0 1 now. LED is not blinking, and 1 1. 1 0 1 0 and 0 1 connection is same. 1 1 is again 0 0. I hope you understand this connection via hardware. Thank you guys. Thank you for watching it.